Hello everyone and welcome to lesson 2.5, algebraic proof. So today we're going to talk about what a proof is and how to complete proofs for algebra expressions. So let's start out with what is it? A proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So basically, when you are doing a proof, you're practicing creating a logical argument, which can be used in many different areas of your life. Let's say you want to convince your mom to buy you new AirPods. If you create a logical argument that makes complete sense to your mom, she's probably going to do it as long as she has the money for it. So logical arguments are a really important part of your life because you use them all the time. If you provide a good logical argument for something, chances are you're going to get your way. So algebraic proofs are some of the easier types of proofs to do, but basically you're going to list every single step and you're going to pair it with the property of equality that was used to get each step. Now, the first step is always going to be the original equation, and it says given next to it. And notice I'm also not showing the work, and it's unusual for me to say that, don't show your work. But what I mean is that you're not showing the in-between steps where you're actually showing -6 on both sides. We're showing the original expression, we're showing the result of subtracting 6 on both sides, and we're labeling that with the property that was used to get this, but we didn't actually show the work of the subtraction. Okay, and the final step in this particular proof is dividing by 2, and that's the division property. Now, proofs are always set up in a similar manner when you're doing 2-column proofs, which is what we are doing. So you always have your statements over here on this side, and you have your reasons on the other side. So it always starts with the statements, your work is over here, and then the reasons why you're allowed to do that work is on the right side. So notice it's almost set up like a table. And you're, like I said, you're not showing the work between these steps, you're just showing the result of what you did. And the result is labeled with the reason you are allowed to subtract that 6, or the reason you're allowed to divide by 2. Now, please note that a good reason is never prove or proven. Don't write that in your proof. That is not allowed. It is not a good reason. So let's take a look at the properties of equality that we're allowed to use in algebraic proofs. Okay, these algebraic properties are properties that you're allowed to use anytime you're creating an algebraic proof, and some of them are going to be very familiar. The addition property of equality just allows you to add something to both sides of the equation. Subtraction allows you to subtract something. Multiplication allows you to multiply both sides of the equation by a number. Division allows you to divide both sides of the equation by a number. So those are the familiar ones. Now, the reflexive property of equality is something that doesn't seem very useful right now, but we do use it all the time. So it seems very weird. It's just that something is equal to itself. Okay, so we do use it all the time. I know it doesn't seem like we will, but it is very useful later on. The symmetric property allows you to switch the sides of the equal sign. So if I had A equals B, then I'm allowed to write B equals A. And again, that's something that doesn't seem very useful, but it can come up. The transitive property gives, it's almost like the law of syllogism. It gives 2 equality statements, and then it skips over the part that's repeated. So if A equals B and B equals C, then I can skip the B's and say A equals C. We use that one a lot too. And finally, the substitution property, which is used all the time. It says if A equals to B, then I can replace any A's in an expression with B's. So you're all familiar with how to substitute something, but there's actually a property that says that. So let's take a look at an example of creating an algebraic proof. Okay, so it says solve the equation -5 equals 3n plus 1 and write a justification for each step. So we're going to start off our 2-column proof by taking our equation And right next to it, I'm going to write the equation, and then I'm going to write given. So that's where we're starting. Okay, so this is our first step in the proof, -5 equals 3n plus 1, and it's given. Next, I would subtract 1 from both sides of this equation. So that would look like this. Okay, notice I didn't show any work. -5 minus 1 is -6, and I'm left with 3n over here. Now finally, I need to divide by 3 on both sides of my equation. When I divided, again, I didn't show the division, but I got a final answer, and I wrote division property of equality. Now at this point, if you prefer to have it say n equals -2, you can use the symmetric property to do that. That's an optional step in this one. So let's take a look at another example. In example 2, it says, to simulate the motion of an object in a computer game, the designer uses the formula SR equals 3.6p. Find the number of pixels the object must travel during each second of animation. In the formula, S is the desired speed of the object in kilometers per hour, R is the scale of the pixels per meter, and P is the number of pixels traveled per second. The graphics in a game are based on a scale of 6 pixels per meter. The designer wants to simulate a vehicle moving at 75 kilometers per hour. How many pixels must the vehicle travel each second? Solve the equation for P and justify each step. So notice what they've done is they've given us an equation, SR equals 3.6p. They've given us a lot of information, but they've also given us some numbers. So 6 is the scale, and 75 kilometers per second is the speed of the object. So we're going to start by setting up our proof. Our given statement always comes first. So we're going to write our equation down, and we're going to say given. So I have my beginning to my proof. Now it does say solve the equation for P. So all I'm going to do is get P alone here. P is multiplied by 3.6, so I need to divide both sides by 3.6. Okay, now that I have that, this is exactly what they told me to do. I can take the numbers that they gave and put them in for S and R. Remember, S is the desired speed of the object, and we want it to be 75, and R is the scale of the pixels, and they told me the scale is 6. So I'm going to put a 75 in for S and a 6 in for R. Okay, and the thing that allows me to do that is the substitution property of equality. I substitute values in for the variables that they represent. So I have this. Now I want to actually just do some calculating in my proof. There's no reason that I need to give other than simplify. Whenever you're just calculating something from one step to the next, you can just write simplify. So I'm just going to do 75 times 6 divided by 3.6 and get an answer. Okay, so I got 125 is the number of pixels. Now the last thing I need to do is I need to write this as a normal answer. So I want to say that it's 125 pixels, but notice I don't have enough room here. So I'm going to use the symmetric property to switch the sides of the equation just so that it is able to be written better. So P is 125 pixels, and that is the symmetric property of equality. Okay, so make sure you watch the next video that has the next 2 examples in it and a few more properties.